So the speed of light equals lambda, which is the wavelength, times frequency. The speed of light also equals, since it's a constant, 3 times 10 to the 8th meters per second. Always remember the units. So if we need to calculate wavelength from frequencies, we can use the equation lambda equals c divided by the frequency. So right now for problem A, we have 625 kilohertz. So we need to convert kilohertz into hertz, and we can do this by doing dimensional analysis to make sure that we always keep track of our units. So 1 kilohertz equals 10 to the 3 hertz. 1 kilohertz equals 1,000 hertz. This means that we have 625 times 10 to the 3 hertz. That is the frequency that we are given. So now we can calculate the wavelength using our equation. So lambda equals 3 times 10 to the 8th meters per second over 625 times 10 to the 3 hertz. So remember that hertz is also equal to 1 over seconds. So that means that this second can cross out and hertz can be crossed out. So that leaves us with, using our calculator, 480 meters. Okay? Now let's go on to the next one, problem B. So with B we have 734 megahertz. So again, we have to do dimensional analysis to convert it to hertz. So 1 megahertz equals 10 to the 6th hertz. So that gives us 734 times 10 to the 6th hertz. So again, using the equation lambda equals the speed of light divided by frequency, we can get, okay, so 3 times 10 to the 8th, again units meters per second, over 734 times 10 to the 6th hertz. Again, hertz is 1 over seconds, so the seconds can cross out, equals, using a calculator, 0.409 meters. Again, remember to have the units meters. Now for problem 3, we have 8.4 times 10 to the 14. So E14 is 10 to the 14 hertz. So we don't need to convert the units here because it's already in the correct units, which is hertz. The E to the E14 is scientific, is how it's written sometimes. So we can just write 10 to the 14. So again, using our equation, we can do lambda equals C over frequency. So 3 times 10 to the 8th meters per second over 8.4 times 10 to the 14 hertz. So again, hertz and seconds can cross out. Plug it into your calculator. You will get 3 times 3.6 times 10 to the negative 7. And then this will be meters. So in your calculator, you will see 3.6 e to the negative 7. E minus 7. So that's just 3.6 times 10 to the negative 7. For the last question, we have 92 gigahertz. So remember, we have to convert the units using dimensional analysis. 1 gigahertz equals, make sure that you review these before you take the test and know these front and back. So equals 10 to the 9 hertz. So that means we have 92 times 10 to the 9 hertz. So again, wavelength equals c over frequency. So 3 times 10 to the 8 meters per second over 92 times 10 to the 9 hertz. Cross out the hertz and seconds, and we get 3.3 times 10 to the negative 3 meters, or 3.3 minus 3.